last stuff to cover is what, 8.4. We're going to talk percentiles and talk about the bell curve. And that is it. And then pretty much what I was going to do is, oh, z-score. Yeah, that's the last thing. Correlation's pretty easy as well to explain. Pretty straightforward. But we'll talk about percentiles, talk about the bell curve here real quick, etc. All right, so imagine for a second, we're going to look at, oh, I've already erased it, was distribution. Distribution. All right, how is data shaped? For this class, all we give a shit about is 99% of the time everything is in a bell curve. Okay, data in a bell curve are what we call a normal distribution. Not one of the 187 genders, but in a normal distribution. All right, normal distribution. How normal distribution data is set up is described on page 352. Normal distribution is described as the following. Number one, it's bell-shaped, meaning it's a nice, so 352. It's a bell-shaped curve. It's symmetric around the center, that center point being x bar, or the mean. The area under the curve is equal to 1 or 100%. I'll come back and explain why. In the perfect world, the mean median mode is the center. We usually just consider it the mean. Go left, right, these values go to infinity. On the y side, think of this as a frequency. Okay, so the center point, you see the most responses. Okay? So with a bell curve, think of it like this. Two things. Number one is it's a frequency distribution. So for this, this is a horizontal number line where your responses, whatever your responses are. So let's say we're ages for a class, whatever it is, okay? So the average age would be here in the middle. And then think about it in the y direction, it's how many people have that value or characteristic. So the further you get away from the center point, would make sense, the values shrink, shrink, shrink. But the closer you get to that average, that middle point, the numbers skyrocket. And they peak at that middle point. When we talk about the area under the curve is equal to 1 or 100%, think about it in terms of this. If I could start at negative infinity, I could start at negative infinity and count every data point. So if I start at negative infinity, the most negative number you can go, and I start counting every data point. Next one, next one, next one, next one. And I go all the way to positive infinity. I will have counted every single data point that is possible. Okay? Negative infinity to positive infinity, I can count every data point possible. Okay? So think about it like this is, I can add those data points up, and I can treat the area under the curve as kind of this probability. Associate a probability with the percentage of data points you can collect. So if I start at negative infinity and go to the halfway point, I will have seen 50% of my data. Or, what is the probability? I will have seen, yeah, about 50%. Okay? So when I say the area under the curve is equal to 1, or 100%, I'm saying that if I could count up every response, I would see 100% of my data. Okay? That is a foot stomper right there. Area under the curve is equal to 1, or 100%. All right? So one thing that we always talk about, not in this class, but in the stats class, we talk about confidence intervals. It allows us to find the middle 95%. That would be this, right there. Okay? Now, the empirical rule, which goes along with the bell curve, says this. And again, if we think in terms of responses. I see it in terms of responses. Okay? If I start in the center point, 1 second. I get scared by that light. I'm just kidding. All right. If I start in the center point here, what our mean is, and whatever that value is, etc. And if I go out 66%, correction, 68% from the center, meaning I go 1 standard deviation away from the center. So this would be x bar plus s. This would be x bar minus s. Okay? And now I say, hey, I want you to count up every data point you see in that range. Okay? So 1 standard deviation, I simplify it by saying STDEV, you are going to find 68% of your data. 1 standard deviation, you should see 68% of your data. Okay? If you go out 2 standard deviations, and there's a nice picture that goes with it on the following page, you'll get 95% of your data. So if you stop and think about that, if I go 2 standard deviations away, there you go, I've got 95% of my data. That's pretty good. That's good. And then if you go 3 standard deviations, law of diminishing returns here, you're going to get 99.7% of your data.
How do you get to 100?
You'll never get, you go to negative infinity. So it's like almost infinite amount of standard deviations. Yep, that's a very good question.
So then the equation just changes to the x bar plus s or plus 2s or plus 3s.
Yep, so if you look on page 353, exactly right. Page 353, the top is a picture that describes the empirical rule. So it helps you understand the area under the curve. It helps you understand, how we count, how we look at this. All right. So for example, one of the next example says, heights for adult males are normally distributed with a mean of 71 inches and a standard deviation of 2 inches. What percentage of adult males are between 69 and 71? Okay, it's just simple math here. It says x bar again was 71 inches, which is 5'11", and standard deviation was 2 inches. It asks in this case, what percentage of adult males are between 69 and 73? So in this case, we take 71, add 2, I guess this is 73, so 1 standard deviation. 71 minus 2 is 69. That's minus 1 standard deviation. So in this case, we know right here, if we just go 1 standard deviation away, we have 68% of our data off that center point. So again, this was our average. That is, I created a scale. So think of it like this: 71 up to 73, down to 69. If we throw a bell curve on it, on the top of it, that'll be, we'll see 68% of our data. This right here.
So that's not 68% of the population is 73. That's just 68% of the data.
Yes, the data that you've collected. Now, you can make the argument with statistics, because this is my data set, this data set applies to the population as well. Yep, that's a good question. Okay? So the empirical data helps us just kind of understand, that bell curve, how that bell curve works. Where we can now come in, and with empirical rule, it helps us solve some questions we may have about data. Okay? And one of the things that we look at is what we call the z-score. This is on page 354. Okay? The z-score. The z-score is set by the following equation. It says x minus x bar divided by s. The z-score measure is the number of standard deviations between some data value and the mean. Okay? So what z allows us to do, x bar is your average, x is going to be your data point, s is your standard deviation. All right. And what we do with this, it allows us to look at each individual data point and compare it to the average and your standard deviation. So it allows us to, again, where's the center point, but then also consider how much variability do we have in the data itself. Okay? It's a very, very easy equation. But then reading the tables and stuff is kind of where it gets complicated. So we'll give you an example. It says for number 2 on page 355, it says, for normally distributed data with a mean of 50, so it says it's normal. That means we can use the z-score. X bar is 50, and the standard deviation is 10. Find z for the following. X is 60. All right. Come up here and use our equation. Z is equal to x minus x bar. So it'll be 60 minus 50 divided by the standard deviation, which is 10. 60 minus 50 is 10. 10 over 10 is equal to 1.
So that standard deviation number 10, that is where we would have gotten from
The table.
that
Yep.
table.
Exactly right.
Which has always been a decimal point so far in all of our
Yep.
equations.
Whole
Yeah.
number's just making it easy.
Exactly.
Okay.
And what was the one that you pointed out? It's like, all of these are 1. The other night, what was that?
Oh, I forgot.
And I was like, nah, it shouldn't be. It's just, they're crappy
I
examples.
remember that conversation. I don't remember what the topic was though.
All right, so we'll do one more here. It says, what if we use 32? If x is 32. All right, x is 32. So in this case, we have z is equal to 32 minus 50 divided by 10. That'll be what? Minus, or negative 18, I think? Divided by 10?
-1.8.
Yep. Negative 1.8.
It's right there in the book.
Yeah, it is. Good point.
And the z-score, so
Yeah.
I know it says here it means it's a number of standard deviations between data value and mean.
Yep.
What exactly does that tell me?
Good question, because that's now the second part to a z.
Oh, okay.
Is where you're headed. Okay, so where we use these z's now is, I'm going to draw a picture here to what I mean by this. So what you do is you take your bell curve. Right? Take the bell curve. Okay, so there I got my x bar in the center. And over here to the right, I'm just going to draw another line, and I'm going to draw x. That's the x that I'm looking for. Using our standard deviation, using that z, I'm just going to write the equation just to put it up here. So this x has a corresponding z value. All right? Where we use this z is, we calculate it, we go to a table. The table will now tell us if we start at negative infinity and go all the way to that value of x, we have a corresponding p-value, or area under the curve, up to that point. Meaning, if I can start counting all my data points, I will have seen so much percentage of the data so far. Okay? Those p-values that we calculate help us identify really how far off center is it.
Okay.
That's really what we use it for. Okay? So what it talks about the next section, example 3 on page 356, says to find the percent, oh sorry, let me back up here. It says not only z-scores tell us the number of standard deviations that a value is from the mean, it also lets us use one chart to calculate the percent of data less than the value, more than the value, or between. Normal distribution, there's a chart that comes with this course that is known as a percentile chart. It's this percentile chart, like I said, that allows us to determine that right here.
Is this a standard chart?
Yes, it is a standard chart. It should be in the back of your book as well.
Okay.
So if you're on the next page, 356 says, to find, so we have a certain z value of negative 2.47. So it's calculated as z equal to negative 2.47. Okay, two things about z's. Number one, if it's less than 1 or less than 0, if it's negative, it's on this side of the bell curve.
Okay.
If it's positive, it's on the right side of the bell curve. Okay? That's number 1. Number 2, bell curve. Negative infinity to the center point is 50% of the data. Right over 50% of the data on that side as well. Alright, so what we do, we have a nice nifty chart, in the back of the book. Let me find it real quick. Page 433 and 432.
There it is.
So these are our charts on 432. 432, 433. That's what they look like. And this is literally how we translate our z's into p's. Someone a long time ago sat down and calculated all these. All right. So to find the p-value for negative 2.47, there are two charts. The one on page 432 is the negative z chart. 433 is the positive z chart. All right.
You gotta round it up to 250.
No. Actually, this is an easy one. So what you do is, on the very far left column, it says z. It'll say z, and scrolls down all the way, starting at 3.0 and goes to 0.0.
Mm-hmm.
Right? So this, I'm not a big fan of these charts. They can be confusing as hell.
Oh, I see. 0.07's over here.
Yep, exactly right. So in this column, you're going to go down until you find negative 0.24. Then on the top, you're going to find the column. You're going to go down the row till you get 2.4, negative 2.4. And then over to the right, you're going to go until you get 0.07. So you'll intersect them together. And for that, you will get,
0.0068.
yep, that's what I got. Exactly right.
Okay. And that's p times x.
The probability of x, of whatever that event is. That's what we
Okay.
just write, px. Yep.
Okay.
All right, so Kev, if I give you another one, let's say I give you a positive one, what is the p-value for 1.15?
0.8749.
Yep, very good. And that's literally how you, that is the quickest I've ever seen anyone learn the chart. Usually it takes people forever to figure out those charts. How to just translate it.
Gotcha. Okay.
And then if you want to do it the other way around, if I give you a p-value, you can find the p-value on the chart and work your way back up to the name. So if I give you a p-value, let's make it easy. How about 0.975? So tell me what the corresponding z-value is of 0.975. So you go into the chart and find this. Find the nearest cell that gets you the closest to that.
Okay. 975. Oh. There it is. Nope. 74. Damn right.
It will be a positive Z. I will let you know that. It will be a positive Z.
There it is. It's gonna be 1.96.
Yep. Very good.
Okay.
So how do we get the p-value though? Like, without using the table? Like you said, if you had the p-value.
You have to use the table.
Oh.
The table is, yeah, you have a Z, I can get to a P. So when it gives you a P, you have to have that table to get to a Z.
But how do they give you the p-value without using the, you know what I mean?
You might have the other way around. Someone might say, hey, the 97th percentile, what is my corresponding Z that I would see?
Okay. So that's, it says right there, percentiles.
Yep.
Okay, so these decimals in the box are the percentiles as opposed to the data value or the data.
Exactly right.
I
Yep.
didn't know that. Makes sense.
Yep, and that's literally, yeah, those charts can be a little confusing. I'll be the first one.
It'd be nice if they would offset them with different shades, so you know where the fuck you are.
Yes, I concur with that statement.
Hmm.
So if I give, what you can also do is you can use geometry to solve. So notice, it goes to negative infinity up to that value of x, right? So if you read 0.97, that means negative infinity up to that z of 1.96.
Mm-hmm.
The p-value would be 0.975, okay? Now, you can also use geometry here to go, okay, if I know this z right here is 1.96, and I get a p-value of 0.97, okay. What would the p-value be between z of negative 150 and z of 196? Meaning, what's the area of this curve that's in green?
Mm.
Okay?
So you'd have to take both those
p-values and do something with them.
Exactly right. So let's play some logic here for a quick second. We said the total area under the curve is equal to,
Was it
right here,
1 or 100%?
100%. So if I know from negative infinity to positive infinity, it's 100%, just like a pie.
Yeah.
And if I go negative infinity to this point, I get 97.5% of the data.
Mm-hmm.
What's this part then?
That's the other small percentage.
Yeah.
That's the-
What is that, 2.5?
Yeah.
Yeah. So we know this small half is 2.5%.
Okay.
Okay? We can use that same logic to discover this. Okay?
Mm.
So how do we calculate that? Well, for this, we find out what our p-value is of z. I'm going to draw the picture to describe it. Determine the area of the curve for this, up to 95%. And then what I'm going to do is I'm going to draw another bell curve, and then determine what up to z of negative 150, or 0.50 is. And now you can magically, you'll get a p-value for that. Take this and subtract it off of that. Cut it off.
So it said negative 1.50?
Yep,
So then that would be 0.0668?
yep. So you take 0.957, so 0.975, sorry, and then subtract, what was the other value you got?
0.0668.
668, yep. And when you subtract that, it's not going to be much of a difference, but
No.
what'd you get?
Oh, I had my other equation in there, I was like,
Oh.
what the fuck? 307.
What was that again?
307?
3 oops.
So it'd be 0.0307.
Yeah. And that's how, for this class, it's all we want you to know, is how to calculate z, understand where z comes from, plug it into the table, and then that's it.
So that's the p-value of that smaller
A for
portion
R.
on the left.
Yep.
Okay. Hmm.
So the foot stompers on this know z, the equation for z, how to calculate it. Know that with the bell curve, the total area under the curve is equal to 1.
Mhm.
Number 2, for every z value is a corresponding p-value that tells me if I start at negative infinity up to that value of x, I have seen this percentage of data, or the percentile of data. And that's as far as we want you to know in this class. In stats, when we pick up next semester, we'll get into detail on this.
Oh, yeah. My wife is, she's like, have fun with that.
That's right, you tell her to come in here, you say, woman!
She hated stats.
Well, good, you're gonna do better than her, so you can be like, I did better than you.
She absolutely hated them.
All right.
She has her degree already.
Oh, see, you're just playing catch up, you're gonna do better.
Yeah.
So.
She's a nurse. She went to nursing school.
Oh, that's right, that's right.
She's fucking too smart to argue with, too. I hate arguing with her.
Nice.
She wins all the time.
All right. All right, the very last thing, and it's pretty quick, because they really don't want you to know about this, and you can figure out reading the book as well, is correlation. 8.5. Correlation, and when we take stats, we refer to it as regression as well. Correlation.
Am I gonna need a ruler and graphing paper for stats?
No. We do a lot of work in Excel.
Oh, yeah?
Yeah.
Okay.
I want you to know how to hand jam stuff, but when we come to bigger data sets, I'll have you like get into Excel.
Okay.
And I teach Excel. No one uses many tab. I mean, people use real world stuff, but I argue that the average person is never going to use Minitab or SAS or anything like that in the world. So to me, it's like, use what they're going to use in life. Excel. Or numbers. The Apple version is just as easy. All right. We talked about earlier in the semester the idea of what we call the dependent and independent variables. We refer to them as X and Y. All right, X and Y, the independent and dependent variables. All right. So with that, we did what I called earlier in the semester. I said you can take those values and plot them on what we call the scatter plot. Meaning that you can take whatever values of X and Y and you can plot them. Where you may get something where you start playing, like, look something like that. All right. Great example I always keep coming back to over and over again through the years is if I ask 20 people, what is your height, what is your weight? You're going to generally see over time, usually when I have more than one person, it's fun to do. But you'll see over the time period, as X increases, as height increases, weight will increase as well. I don't know a lot of 5'4" people that weigh 200 pounds. If I do, they're overweight. Exactly. So that is something that you will see. That is a trend. Correlation. Correlation is that relationship that we have. Okay? Correlation, and for this class, and most of them, we refer to as linear correlation, meaning a line. Just a line. Okay? Correlation is do we have a relationship between X and Y? Meaning, as X increases, does Y increase? As X increases, does Y decrease? Correlation is us identifying that relationship. When you get to regression, the part we don't talk about here, you talk about the best fit line. Or if I could look at this data, as I move in this direction X, I see that Y increases. My responses are increasing. Yeah, that would be what we call a positive correlation. Okay? In this case, this would be a positive linear correlation. If it goes in the negative direction, I'll put on green dots now. So if it looks like this, that would be negative correlation. Okay, so if it's going to positive, so it's going up, it's positive. down it's negative. Or maybe, I'll do a third color here, you literally just have this. I just threw black in there. I know it kind of makes this muddled now. But you may not have correlation at all, meaning that I don't see any increase. It's just kind of sitting there. I think, let me see if I can find it. There's a good picture in here, I thought. Page 367, the bottom left corner. What we're talking about here is what they call the R value. The R value defines how good of a relationship do we have. So if you have a perfect relationship, like your marriage is absolutely perfect, which it never is, it'll have an R value of 1. If it's -1, that means it's going in the negative direction. If it's +1, it's going in the positive direction. At the very bottom left corner, is an R value of 0.03. Notice when you look at the data, it's just scattering. That is no correlation. You can look at the other ones and you can still kind of see relationships. 0.76 positive, it's going in the positive direction. So number one is there a relationship? And then the R value, which goes from -1 to +1. All right? If it's 0 or closer to 0, it means it has no relationship. All right? No relationship. All right? For this class, literally, for correlation, we want you to be able to plot the data points and just look at the picture and go, yep, looks positive to me. Looks negative, it doesn't look like a relationship to me. And then what they also do is they'll give you an R value and they'll turn around and go, is this good or bad?
That seems pretty simple enough.
It's very simple. This is it's very simple stuff. So for example, if I look on page, okay, the plotting part, we'll skip that. 372. 372, that problem 7? Oh, sorry. There's these charts, A, B, C, D, E.
Yep.
And then it says, on the next page, 373, it says, state which graph has the following correlation coefficient.
Ooh.
So, yeah, we got 7, 8, 9, 10, 11. Okay. We'll skip to 8 and 10. 8 is -1.
Yeah, that's C.
Yep. And 10 would be which one?
B.
Yep. How about 11? Which one would 11 be?
Let's say it's probably, I'd like to say E, but they're both going down. They're both going negative. They don't seem as sporadic as say, well, no, yeah, I'd say E.
Okay. Look at A for a second.
Well, yeah, it's kind of a shotgun blast, isn't it?
Yeah. It's literally just across the middle.
Yeah.
Nothing
Makes more
increases,
sense.
nothing decreases, and it's just kind of there.
That makes sense, yeah.
Yep. And then -0.72 would be E.
Yeah, that'd be E.
Yep.
Oh, okay.
And that's literally what we want you to know for correlation.
Oh,
That's super easy.
that's easy.
Usually, what over the summertime, I really had to focus on mean, median, mode, standard deviation. But then, like I said, what I really focus on with those is follow the table. Just
Yeah.
set up that table, etc. Whatnot.
Oh, shit.
Any questions on that part?